In this session, I'm going to talk about domain decomposition, or let's say chunking. We might try to divide the data into chunks, and we can define some regions that a block is going to use instead of, letting Alpaca decide the work division, and each block uses the corresponding data by using the index. So we can change this idea and we can divide the data and we can assign a chunk to a block deliberately. Therefore, chunk could be larger than a block, for example, and a block could process more data than the number of threads in it. And this is why this is used, because domain decomposition sometimes necessary if the data is too big, or we need to use shared memory, which has a limited size of the GPU. Therefore, chunking is an important approach. And how we are going to divide the data and make a block use only one chunk, but chunk size could be different than the block size. A block can process more data which exists in a specific chunk. Therefore, this is actually the concept of domain decomposition. A block of threads is going to update a chunk of hit data. This is the idea. And again, a grid of threads is going to update the whole domain as before. And in this case, hollow region, which is not something physical. I mean, we define a hollow region because our hollow region with a size of 1. And why? Because our stencil is 3 by 3, and it's not something physical. We create a hollow region to in the software, in the code, and to make the stencil operation easy. Now, but sometimes hollow, of course, may coincide with the boundary, or it might not coincide. Like here, we are going to define chunks, and stencil operation will go over the chunk, not the whole grid, considering a block of an operation of block. Here, again, hollow size is 1. And the stencil is a 5-point stencil. Chunk size could be larger than the block size. Yeah, it is. It shouldn't have to be the same. For example, here we are. A block is responsible to process a chunk with hollow. Why hollow is needed? Because of our stencil operation needs other data than only the data inside the chunk. Okay, this is the responsibility of the block to update the heat data. And as you see, we are currently using global memory, and we are just dividing the data in the global memory, and we are not using shared memory in this example. But it is also a good exercise and preparation. This is the idea. Yeah, we can set the work division fields directly depending on our chunk size. And we are not going to let Alpaca calculate a work division for us, but we are going to select here the work division using our chunk size information. This is the idea actually, and yeah, that's all.
So Mehmet has introduced what we need to do in case we want to distribute our work in chunks to all the blocks that we are running. So yes, question.
Well, maybe I don't understand well, but then if we work with this chunk way, what is the main difference with the previous one? Because as far as I see it, previously all the blocks were concerned with a part of the domain, so they already had like this domain decomposition kind of way to work. So what's different now with the chunk?
Yeah, a block was responsible only for the data, which is equal to the block size. Block size, let's assume that block size is 12, and then 12 threads were processing 12 points. Now chunk size could be bigger than the block size. This is the idea. Each thread is going to process more data because the block size can be small and chunk size can be like this, and the block again is responsible for the whole chunk. This is the idea. Therefore, we cannot use directly the data domain to get the work division directly from using alpaca function, because each block is going to work on a larger domain. This is the idea.
And I think that's a very important concept, that alpaca gives you a distribution and a mapping of the worker threads, and mapping of those threads to your data is a separate step that is often one-to-one, but not necessarily. And that is what the user decides.
So far, it was this one-to-one.
Yeah.
Okay.
Yeah. So the comments in the room are that alpaca really separates the mapping of your data to the worker threads, and this can be one-to-one or it can also not be, and alpaca gives you the complete freedom to change this. And this is quite important in most cases because you know how your problem should be decomposed. You know how many nodes you want to run on, for example, or what the parallelism, how you want to exploit the parallelism is completely up to you. And you don't have to let alpaca decide it for you. You can do this yourself as well.